Okay, lesson 8.3, modeling periodic behavior. And in this lesson, we're going to be graphing functions. So it is a little bit challenging. So as always, if you need to watch it a couple times, please do so. Okay, so make sure you have all these notes if they're not already printed for you. We've discussed period and amplitude in the previous lesson. Now these notes were given to you already, but we didn't actually use them. So your phase or your horizontal shift, as with any translation of a parent function, comes from the opposite of what's being added or subtracted in the function, okay? Vertical shift, how we're going up and down on the function, that's always the same as what's written in the parent function. Okay, and that vertical shift is very important when we get to graphing, and I'll continue to come back to this. This axis of the wave that your book calls it, we find it looks a lot like the amplitude, but now we add the max and min together and divide by 2, and that's what I'll refer to as the midline of the graph. Okay, so I've tried to make this as easy as possible for you as far as exactly what to look for. So we're going to ask that you graph one period of the function, because if you can graph one period, you can graph an infinite amount of periods. So the period to graph, we're going to go 0 is less than or equal to the phase shift, which will be less than or equal to 2 pi divided by b. And hopefully this is recognizable as the period of the function. Okay, we have that over here. The increment is the period of the function divided by 4. And what the increment represents is the spacing on the x-axis. And then, of course, what's the parent function? It's either going to be sine or cosine. Sine starts and ends on the midline. Your cosine starts and ends at the value of a. Okay, and let me go back to this real quickly. So your phase shift is going to be that expression x minus c from your graph. Okay, so that is going to be important. All right, so let's look at some examples. Now you have the graph paper, so I'm going to be working, on both, but make sure that you're working on the graph paper and putting your notes wherever you need to. So we're going to sketch sine x plus pi. So label that on your graph paper. Okay, from my equation, a is equal to 1/2 and b is equal to positive 1. Right? There's no number that is that's written out front of the parentheses, so I know b to be 1. So I know my amplitude is 1/2. Okay, period is 2 pi divided by b, so the period of the function is just 2 pi. The phase shift is left pi, okay, because it's the opposite of what I have written in the equation. And your vertical shift, there is none. So that means your midline will be at the equation y is equal to 0. Okay, so those are the things we can determine just from the equation. Now let's go back to these 3 pieces that I added. So the period to graph, so 0 is less than or equal to the phase shift. Okay, and the phase shift comes exactly from the equation, which is less than or equal to the period of the function, right? That 2 pi divided by b. Okay, so if I solve this inequality for x, I would have to subtract pi from each part of the inequality. So I get negative pi is less than or equal to x, which is less than or equal to pi. So that's all I'm going to look at along my x-axis. All right, so secondly, the increment, the spacing along the x-axis. I take the period of the function, which is 2 pi, and I divide it by 4. So my increment is pi over 2. And then lastly, your parent function. Your parent function is sine. So sine of x, its parent function looks like this. Okay, and I'll come back to the importance of that. So now let's look at actually writing the function here. So my midline is y is equal to 0. Y is equal to 0 is just my x-axis. So my graph is going to start and end on the x-axis. Now, because we have the space, I'm going to go in increments of 2. Or units of 2. I don't want to confuse you with increment. So this is where I'm going to start my graph, at negative pi. An increment of pi over 2 means if I'm at negative pi and I add pi over 2 to that, the next value that I want you to write on your x-axis would be negative pi over 2. So negative pi over 2 goes there. If I add pi over 2 to negative pi over 2, that'll put me at 0. 0 plus pi over 2 is pi over 2. Pi over 2 plus pi over 2 is at pi. So now notice where I start and end better correspond to the period that we already determined. And how do I get the values? I get the values by adding that increment there. Okay, sine starts and ends on the midline. Now check out the parent function, and this is extremely important. The behavior will always stay the same. So on the sine function, I'm at the midline, maximum, midline, minimum, midline. And each of these values are the values we already determined from the period to graph and the increment. So to graph, we got to put in our amplitude. Our amplitude is a half. Okay, so I'm going to make this a half, so we're not cramming it too much, and that would be a negative half. So now using those 5 points, midline, maximum, midline, minimum, midline. When I take a smooth and continuous curve, right, make sure none of these are line segments. To sketch that, there's my parent function sine. It's just translated to the left pi units. Let's look at another one. So label your graph. Negative 2 cosine of pi x plus 1. A is equal to negative 2. B is equal to pi. Okay, so our amplitude is the absolute value of A. So our amplitude is 2. Our period, 2 pi divided by pi. So the period is also 2. Phase shift, there is none. Okay, nothing is in a set of parentheses being added or subtracted to the x. Vertical shift is up 1, which means the equation of our midline is at y is equal to 1. Okay, there'll always be horizontal lines. So now to graph, what period are we looking at? So 0 is less than or equal to our phase shift, which is less than or equal to 2 pi divided by b. Phase shift comes from the original. Nothing was being added or subtracted. 2 pi divided by b is exactly what we get here. Okay, so those things are going to change. They can change for every single equation that you're graphing, because obviously the information that you're given is different. Okay, next our increment. So how do we move along the x-axis? The period of the function divided by 4. So I'm going to move in increments of half of a unit. Our parent function is cosine, but since a is negative, sorry that the pen's doing that. Since a is negative, my parent function is going to be the reflection of what the cosine graph is. So let me take all these things out of here. Okay, so it's a reflection of the parent function. So I'm going to start and end at the negative value, okay, below the midline. Okay, so let's graph. Y is equal to 1, my midline. I'm going to put a dotted horizontal line there. Now your amplitude is the height from the midline. So if my amplitude is 2 units, that means that the maximum of my graph is going to be at 3, and the minimum of my graph is going to be at negative 1. Because from the midline, I'm moving 2 units up and 2 units down. Okay, so my period to graph is from 0 to 2. That's what goes along my x-axis, and I'm moving in increments of a half. So there's 0. And I'm going to, do I have room? 1/2, 1.52. Okay. So I'm going to, just to space it out so you can see, I'm going to make each block equal to a quarter. So that's a quarter. So there's a half. Then 1, 1.5, and 2. And again, the only reason I did that is so that I don't have to squeeze everything in here. Okay, so my increment from point to point on the x-axis, I move a half of a unit. I start at 0, I end at 2. Okay, so now just like the sine function, those points on the increments gave us specific points on the graph. Now let's check out cosine. So I'm going to start at my minimum, midline, maximum, midline, minimum. Cosine always starts and ends at the same spot. It's either going to be above or below the midline. So the first point on my period to graph, minimum, midline, maximum, midline, minimum. Okay, those 5 points are never going to change. What changes is the max, the min, and what the actual increment is. So I take a smooth and continuous curve to sketch that, and mine are not great on the computer here. Not that they're great by hand either, but just make sure they're not line segments connecting these points. These are smooth and continuous curves. All right, let me at least introduce the next one. Okay, so this order is a little bit different. So the first thing I'm going to do, I'm going to rewrite, I'm going to put my +4 at the end. Now notice, okay, if you go back to our original notes, A, sine or cosine, B has to be out front of the set of parentheses. Right now, it's not, okay? I have to factor B out of the set of parentheses. So if I'm going to factor a 2, because that's the coefficient to the x, okay, if I take a 2 out, remember, factoring is dividing out, so dividing by the 2 is easy for you guys to see. But if I take pi over 2 and I divide it by 2, that's the same as saying pi over 2 times 1/2. So the phase shift that remains inside the parentheses needs to be a pi over 4. Okay, so let me rewrite what we have here. Y equals negative sine. I factored the 2 out, leaving me with x plus pi over 4 in the parentheses, and then the +4 stays put. Okay, so now let's identify all the information. A is equal to -1, and now we have B is equal to 2. Amplitude is the absolute value of -1, so the amplitude is 1. Our period, 2 pi divided by B, so the period is pi. The phase shift is left pi over 4 units. Vertical shift is up 4, which gives us an equation of a midline at y equals 4. Okay, I'm going to erase this stuff since we already talked about it. And I'm under the wire here for time. So our period to graph (0) is less than or equal to the phase shift, which is less than or equal to the period of the function we determined. Right? Pi comes from here. And then the phase shift has to be after we've already factored out the 2, or whatever value it might happen to be. And I didn't solve that again just for time's sake. Your increment would be period over 4. Okay, so try and finish this problem. Solve this for x and attempt to graph the function for yourself. All right, I'm going to put the factored form up here. All right, finish.